So we now have our concepts of voltage, current, and resistance. But first, we need to make a distinction between different components that will appear within our circuits. We can loosely define them into two categories: active and passive elements. You can think of active elements as components that do the heavy lifting and provide the actual energy for the circuit, like a battery. Passive elements are the opposite. They cannot provide energy to the circuit, but they can expend it or hold it for other components. Resistors are an example of expending that energy. We'll see two other components that can hold energy, known as capacitors and inductors. Let's first take a trip down history lane. As of many great scientists who finagled with electricity, there was a crazy guy playing around with experiments. He was building on the ancient Greeks who discovered static electricity with the amber and feather experiment. He wanted to see if he could store that energy into a container. He did so by generating that static electricity with a machine and connected it with metal rods into a salt water-filled container. To his odd surprise, he discovered even after removing that static electricity generating machine, he would get a nasty shock. The crazy guy's name, Musin Chenbrok, I probably pronounced that wrong, discovered capacitance, the ability to store energy or charge. Another person named Maxwell looked closely into the relations of electricity and magnetism and found that these two phenomena were actually linked closely together. He is responsible for creating a set of equations that determine much of our knowledge today, which lead us to harnessing them separately through our circuit components, capacitors and inductors. Capacitance is the ability to hold energy or charge. An example of this is a camera flash. When taking a picture, a large amount of light is released to illuminate the target, making you look photogenic with squinty eyes. Essentially, something must hold all that energy bundled together before suddenly releasing it. The capacitor acts as a storage unit for this energy. However, where does this energy come from? Since a capacitor is a passive element, it cannot provide its own energy. Rather, it utilizes other resources such as batteries to store the energy, since energy can't come out of nowhere. Capacitors simply store the energy for future use. Capacitors are the main circuit components within a circuit designed to hold charge for other components. Capacitors are usually denoted with this such symbol, since the easiest way to create a capacitor is made of two parallel electric plates. Either symbol is preferred, but I like the one on the left, since the other one looks funky. The unit of capacitance is in terms of farads, which are very large, which is why you usually see most capacitors in terms of micro or picofarads. The two most common capacitors are ceramic and electrolytic capacitors. The most obvious difference between them is that electrolytic capacitors have a polarity, while ceramic ones do not. We now come to the topic of magnetism. It is a difficult phenomenon to talk about, since no one knows what's going on. However, at a high level, changing magnetic fields can cause a change in electric fields, and vice versa. We get this complicated mess of fields affecting each other, and the inductor was produced from this. A good example of an inductor is a rechargeable flashlight. By shaking the flashlight, you are moving magnets within the device that are moving and creating new electric fields. This converts the magnetic energy to electrical energy, which you can use. Our good friend, the inductor, is responsible for this little bit of magic. Inductors are special components that utilize magnetism to cause voltage when the current flowing inside them changes. On a circuit diagram, this is the symbol used to represent them. However, there are many different variations involving inductors with different sizes and shapes, all meaning slightly different things, but still utilize the properties of the inductor. Another way to think of an inductor is a highway. On a highway, the cars keep driving forward without stopping. Similarly, in the circuit, the flowing electrons in the current are carrying energy, and the inductor is constantly pushing that energy through. The energy tends to stay in motion and likes to continue going in one direction. So hopefully in this video you learned about more types of circuit elements and how they are classified.